everybody. So now that we covered the graphical method to add vectors, let's talk about the analytical method, which is to decompose vectors into components, and then you add up the components to get the resultant. So I'm just using the same example from last week. So here is vector A. Let's split it up into components. So you just look at the magnitude and then the angle, and you can just, it always works, just cosine 60. Right. And then in the y direction, 16 sine 60 degrees. And then same for B, the magnitude, direction. You can just plug it in. 14 cosine negative 160. Let me leave some space so I can plug in the numbers from the calculator. And then magnitude, 14 sine negative 160. Okay, and then if I punched in the numbers from the calculator, which I did earlier, it's 8 and 13.9. And then for B, negative 13.2 and negative 4.79. Okay, so to get the resultant, you just add up the components. So AX plus BX becomes RX, the X component of the resultant. So I punched that in the calculator earlier. And then AY plus BY is, okay, so this is the resultant in component form. If we want the magnitude and direction, right, then let's just like this, right? That's the magnitude, and then I just punch the numbers in. Okay, that's the magnitude, and then for the direction, arctangent y over x. Okay, note that the y component is positive, the x component is negative. Which means it's somewhere over here in quadrant 2. Right? Y is positive, x is negative. It's over here. But when I punch this in the calculator, the calculator said negative 60. Which then I look at that and like, that doesn't look right. Negative 60 is over here in quadrant 4. So I know that I need to flip it over 180 degrees. So I know that I need to add 180 to get it from quadrant 4 into quadrant 2 where it's supposed to be. So I know that the answer is supposed to be 120 degrees over here, like this, over here. Okay, so that's analytical method. Let's try the other example. Okay, so let's say we have these two vectors. They're already in component form, so it's kind of like not much to do, right? Just add ax plus bx, ay plus by, so it's the resultant. Ax plus bx, ay plus by, negative 8 plus 4. Right, so then that's it, and then I know that negative 4i, negative 4j is over here in quadrant 3. So I know that the angle is like this, right? Somewhere between 180 and 270. And I mean, you could do this in your head, right? But if you want the magnitude, 4 squared plus 4 squared, right? Just punch punch that in the calculator. The angle, arctangent of ry over rx, and punch that in the calculator, and the calculator says 45 degrees, which is over here. I know that's not right. I know the answer is supposed to be in quadrant 3, so I know I need to add 180 degrees to get that. And if we just compare to the graphical method, right, we got like 5.5, which is pretty close. We know that this is for sure correct. The analytical method is exact. So the graphical method, not too bad, 5.5. The correct answer was 5.66. Analytical method, we got 225 degrees. Graphical, we got 225 degrees. So that was pretty good. Let's look at the other example. The magnitude was 10.4. Using ruler and protractor, we got 10. It's not too bad. Analytically, the answer correct is 120 degrees. We got 117 using ruler and protractor. Not so bad. Okay, let's try this using some simulations. So let's switch over back to Laulima. Okay, back in Laulima, if you scroll down a little bit, you see like this link over here, which takes you to a simulator. So just give it a try. Okay, and then let's use this one, Explore 2D. Okay, so let's try that same example, the first example. So it was 16 at 60 degrees. So I'm gonna grab this vector A over here, just put it here at the origin, and then we wanted, and then here you can move the coordinate system around, however. Okay, so you just drag, and then watch up here, right? This is the magnitude and the direction, and we want 16 at 60. And we can't get it exact, but just for practice, so you get a feel for what's happening. So 16, oh, that's not a good. Okay. Yeah, that's close enough, right? 16.1, 60.3 degrees. Good enough. Okay, next vector, 14 at minus 160. So I'm going to grab vector B and then put it, when you add vectors, head to tail like this, right? Okay, and then we want 14 at minus 160. So, oh, there's pretty good, right? 13.9 minus 159. It's close. And then up here, there's this button sum. So this is the resultant right here. And it should look like this, right? When you add them. And the answer, 10.3 at 119 degrees. Not so bad. Okay, let's try the other example. So let's get rid of, let's put this back. Okay, vector A is 6i minus 8j. 6, and now I'm looking at the components here. 6 and minus 8. So right there. Vector B, minus 10 plus 4. So drag this, and then head to tail, right? Minus 10 plus 4. There you go, minus 10 plus 4, and the resultant is right here. The negative 4i, negative 4j, 5.7, the magnitude, angle, minus 135. Okay? Alright, so thanks for listening. I'll see you on the next video.